All right, let's get into it. I want you to picture this. You're standing in front of a supercomputer, one of the big ones, and your job? To upgrade its very core, its brain, its most basic operating instructions. This isn't your average software update. Oh no, this is a high-stakes precision procedure. So today, we're going to break down the exact protocols for high-performance computing server firmware deployment. Consider this your official briefing.
So here's our plan of attack. We'll start with the mission briefing, get our heads around the deployment matrix, then we're executing 3 distinct protocols: Alpha for a total system upgrade, Beta for a more targeted BIOS flash, and Gamma for doing it all remotely. And finally, we'll run a full system verification to make sure the mission was a success.
Okay, first up, the mission briefing. Understanding this deployment matrix is absolutely key to getting this done right. So let's take a closer look.
This right here is our master chart. It outlines our 3 protocols. You've got Alpha, which hits both the BIOS and the Server Platform Services, or SPS. Then there's Beta, which just targets the BIOS. And finally, Gamma, which takes care of the BMC, the Baseboard Management Controller. But look at that last column. That's the critical piece of intel. See how only Protocol Alpha requires a hardware jumper? That's because the SPS firmware has its own write protection, and a physical switch is the only way to get past it. That is a hugely important distinction.
All right, let's get our hands dirty. It's time to execute Protocol Alpha. This is the big one, the most comprehensive mission, updating both the main BIOS and those server platform services. We're talking a full system overhaul here.
Every good mission starts with solid prep. Think of this as your pre-flight checklist. First, you're going to format a USB drive to FAT32. Simple enough. Second, you need to get your tools. That's the AFOE Fix64 utility and the BIOS file itself. And last, and this is important, just drop both of them right into the root directory of that USB drive. Don't put them in folders, don't get fancy. Just the essentials right on top.
And here we are, the one physical step that makes Protocol Alpha what it is. You have to find the JPFLSSEC1 jumper on the motherboard. By moving that little piece to close pins 2 and 3, you are physically initiating a hardware override. It is the only way to turn off the SPS firmware's write protection. This step is absolutely non-negotiable. You can't do the full flash without it.
Okay, the hardware is prepped. It's go time. Boot up the system and get ready to hit F11 to bring up the boot menu. From there, just choose your USB drive. Once you're in the UEFI shell, you just need to navigate to your drive. It's almost always FS0. Then you type the final command, flashall.nsh, and hit enter. That little script right there is what kicks off the whole party, updating both the BIOS and the SPS.
Mission Phase 1 is a success. Now let's switch gears and move on to Protocol Beta. This is a totally different kind of operation. It's not a complete overhaul. Think of it as more of a surgical strike, a focused mission that targets only the server's BIOS. We're leaving the SPS alone on this one.
And this slide just lays out the difference perfectly, doesn't it? On the left, Protocol Alpha, BIOS plus SPS, and you need that physical jumper. On the right, Protocol Beta, BIOS only, and, you guessed it, no jumper required. It's a purely software-based operation. Much simpler in that regard.
Okay, I need you to pay really close attention here, because this is a mission-critical detail. The command for Protocol Beta is flashmain.nsh. Let me say that again, flashmain.nsh. That is not the same thing as flashall.nsh from our last protocol. If you use the all script by mistake, especially without that jumper set, it could fail, or worse, cause some serious system instability. You have to verify your command here. It's paramount.
And now for our final protocol, Gamma. This is our remote operations mode. This protocol lets us update the server's baseboard management controller, the BMC, from anywhere on the network. The BMC is basically the brain of the server's remote management, so this is a really powerful tool.
So, with Protocol Gamma, you actually get 2 tactical options. You can use the nice, easy web interface for a more visual, hands-on approach, or if you're feeling adventurous, you can use the command line, which is perfect for speed and automation, especially if you're managing a whole fleet of these things. The choice is really yours.
Now, if you go with the web UI, the process is pretty straightforward, right up until you hit step 4. And let me tell you, this is the most critical decision in this entire sequence. You must, and I mean must, select full flash. Why? Well, if you try to flash only selected sections, you can create a version mismatch inside the firmware, and that can corrupt the BMC and completely brick the device. Seriously, full flash every time.
And for you command line operators, here's your syntax. You're going to use a tool called Yahoo Flash. And as you can see, it's pretty logical. You just specify the target IP address, plug in your username and password with the -U and -P flags, and then point it to the firmware file using the -PC flag. It's fast, it's efficient, and it is perfect for scripting updates across a ton of systems at once.
So all our deployment protocols have been executed. But hold on, the mission isn't over just yet. We are now entering the most important phase of all, complete system verification.
All right, time for our post-mission debrief. Let's run the checklist. We've confirmed the new BIOS version. Check. If we ran Protocol Alpha, we've confirmed the new SPS version. Check. We've verified the new BMC version is up and running. Check. And finally, and this is just as important as anything else, we have confirmed that the JP Flash SEC1 jumper is back in its secure default position. With all systems green, this server is officially mission ready.
So there you have it. We've gone deep and successfully navigated the complex protocols of server firmware deployment, from physically moving jumpers on a motherboard to executing remote commands. So that just leaves one final question. Now that its core systems are enhanced, its capabilities expanded, what new frontiers of computation and discovery is this machine ready to explore?